Good morning, guys. Today I will go over quadratic functions and models. So first of all, we will discuss about polynomial function and a special type of polynomial function, which is quadratic functions. And we will also discuss how to draw the graph of the quadratic function and the vertex formula and the quadratic models. So first of all, we'll talk about the polynomial function. So you guys know that if you have f(x) equal to ax plus b, so what is the name of this function? F(x) equal to ax plus b. This is what is the name of this function? Linear function. Is that right? If you have f(x) equal to ax squared plus bx plus c, where a is not equal to 0, okay? So what is the name of this function? Ax squared plus bx plus c. This is a, what is this? Yes, this is quadratic function, right? So this linear function is degree 1 function, right? And this is a quadratic function is degree 2, right? And now if you have f(x) equal to ax cubed plus bx squared plus cx plus d, where a is not equal to 0, so this is cubic, degree 3, right? So all these are polynomial functions. But if you want to generalize the polynomial function of degree n, you can simply write down f(x) equal to an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus blah 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 plus a1x plus a0. So where an is not equal to 0 and an minus 1, they are real numbers. Like if you have an here, an minus 1, all the way up to a1, a0, they are real numbers. So this is the general form. It looks like a little bit complex, right? So these are the special cases, you know what I mean? So this is a linear function, degree 1. This is a quadratic function, degree 2, right? And this is a cubic function, degree 3. But if you generalize them, you see what I'm talking, right? So this is the what? Polynomial function. Now let's say, hey, if I plug in n equal to 2, look here, you can see that, okay? So if I plug in n equal to 2, so what does it look like? Look here, so we have f(x) equals to n equal to 2, so this is a2, is that right? And then this is x to the power 2, make sense? And now, if I plug in n equal to 2, what is 2 minus 1? 1, a1, x to the power, what is 2 minus 1? 1. Make sense? Plus, if I plug in 2 here, this a, 2 minus 2 is a sub 0, right? And then x to the power 2 minus 2 is what? 0. So when you reach 0, you stop. You know that? When you get a0, you stop. That makes sense? Now, what do you have now? So this is f(x) equal to a2x squared plus a1x plus a0, what is the value of x to the power 0?
0.
X to the power 0,
Or 1.
1. Any number to the power 0 except 0. 0 to the power 0 is not 1. But all other numbers other than 0, right? All the numbers other than 0, when you raise to the power 0, that will give you 1. That makes sense? So now you got fx equal to a2x square plus a1x plus what? A sub 0. Are you with me? So now you see this a2 is not equal to 0 here, okay? So a2 is not equal to 0, and a2, a1 and a0, they are real numbers. They are what? Real numbers. Real numbers. Does that make sense? Now, so let's say, because these are real numbers, so if you replace a2 by a, you can replace a2 by a, right? Because a is also real number, right? Ax square plus, if you replace a1 by b, bx. If you replace a0 by c, right? So where a is not equal to 0, what is this? This is exactly what? Quadratic function. Did you see that? So this is like if I plug in n equal to 1, now here, look here. If I plug in n equal to 1, n equal to 1, look here. So this will be fx equal to a1 x to the power 1 plus a1 minus 1 is a0 x to the power 1 minus 1 is 0. So that will give you fx equal to a1x plus what? a0. Right? Right? And now if you look here, this fx equal to a1x plus a sub 0, but this a1 and a0 are real numbers. Are real numbers. That makes sense? And then if you replace this a1 by a and a0 by b, because they are real numbers, you can replace by, if a and b are real numbers, you can do that. Now this is what? This is linear function. Does that make sense? Yeah. Did you get it? So this is more generalized, more general. You know what I mean? General form. Now today we will talk about this function. So this is a quadratic function, and a is not equal to 0, because if a is 0, what will happen here? It is no more quadratic. So that's why a is not equal to 0. Right? If a is 0, look here. If a is 0, what will happen? So you'll have fx equal to, so this is 0 times x squared is 0, and so you will have what? Bx plus c. This will be what? Linear. That makes sense? So that's why a is not equal to 0. Okay? So, yeah. If you look at the slides here, right? Look at the slides. So if you have fx equal to 2, so that is a constant function, right? And if you have fx equal to 5x minus 1, that is a linear, right? And if you have fx equal to 4x squared minus x plus 1, that is quadratic. And what you need to know is, hey, this a here, the coefficient of x squared is a. This a is a what? Leading coefficient. And here this b is a leading coefficient. This a n here is the what? Leading coefficient. Does that make sense? Are you with me? So this a n is what? Leading coefficient. right? Okay. So you got it, right? I mean, like we talked about, and if you want to give the example, like this, you see fx equal to 2 constant function, fx equal to 5x minus 1. So this is also a linear function. Okay? So now this is the quadratic function. A function f is quadratic function if fx equal to ax square plus bx plus c, right? A function is a quadratic function if fx equal to ax square plus bx plus c, where a is not equal to 0 and a, b, and c are real numbers. That makes sense? So this is a quadratic function. Now the simplest quadratic function is fx equal to what? X square. The simple, or you can say the simplest quadratic function is fx equal to x square. And if you want to, do you remember the graph of this quadratic function? The graph looks like what? The graphs look like this. The parabola, vertical parabola open, upward, right? So let's look like this. Does that make sense, guys? And then like you see the graph is right over there. And if you want to find out the domain, so what is the domain of this parabola? What does the domain look like? What is the domain? Yes, the negative infinity, comma positive infinity. Every quadratic function has the domain negative infinity, comma positive infinity. And what will be the range? You know the range is the set of y values, right? So what will be the range? You have this is the vertex. This is 0 all the way up to what? This is your x-axis, this is your y-axis, right? So 0, comma, positive, infinity. So this is the range. The domain is that, range is that, and we know the graph is this, okay. Now, you see the parabola is symmetric, right, with respect to a line. In this case, this parabola is symmetric with respect to what? Y-axis, right? Right? This is symmetric. This is symmetric with respect to what? Y-axis. And you know the equation of y-axis. What is the equation of y-axis? What is the equation of y-axis? X equal to 0, right? This parabola is symmetric with respect to the what? Y-axis. And so y-axis or x equal to 0 is the line of symmetry. So, or you can say the axis of symmetry. So this y-axis, which is x equal to 0, is the axis of symmetry. Make sense? This is the axis of symmetry. Y-axis or x equal to 0 is the axis of symmetry. Or simply you can say axis of parabola. Okay? And the point where the axis of symmetry intersects the parabola is called the vertex. Like this is your parabola and this is axis of symmetry, and this axis of symmetry intersects the parabola at origin. Is that right? In this case, right? So origin is the vertex. 0, 0 is the what? Vertex. That makes sense? So now look here. So you can have a parabola open up like this, or you can have a parabola open down like this. So the parabola is symmetric with respect to a line, like this is the line, you see that? And this is the axis of the parabola. Or you can have this. This is called what? Axis of the parabola. And the axis of the parabola intersects the graph of the parabola at some point. That is called what? Vertex. This is the vertex, and this is also what called? Vertex. And this parabola open up, and that one is not open down. That makes sense? Now, you see this is the parabola fx equal to x square, and if you have let me write down here. So let's say this is the simplest parabola y equal to x square. Okay? So this is given. So this is given, okay? So now if you have a parabola, let's say a parenthesis x minus h square plus k. So the parabola, if a is positive, the parabola open up. Are you with me? If a is negative, the parabola open down. You have to understand this. Right? If a is positive, the parabola open up, and if a is negative, the parabola open down. So what I'm saying is, let's say you have a so this is given, right? So let's say you have a parabola y equal to x minus 1 square plus 3 in this form, right? So what is the value of a here? 1. So this parabola, the graph of this parabola will be open up, because a is equal to 1. This is what? Positive. Okay? And then the next thing is, you see here, so this is open down if a is negative. And then if the absolute value of a is greater than 1, it will be vertically stressed. So this will be what? Vertically stressed. So if, right? So if 0 is less than absolute value of a is less than 1, if the absolute value of a is between 0 and 1, it will be vertically shrunk. You see remember the last time we talked about that, the vertically stretched and vertically shrunk? Vertically stretched means the graph will be what? Narrower. Right? You see that? We talked about that vertically stretched and vertically shrunk I think like last week. And then the other thing is this, if you look here, this h, if h is positive, you move the parabola h units to the right. Remember that, like last time we talked about that. If you have a function y equal to fx, and the graph of y equal to f of x minus h is shifted h units to the right, right? If h is positive, right? So the graph of this is shifted h units to the right. And if you have x plus h, so this is shifted h units to the left. Remember that? It's the same thing here. So if h is positive, you shift the graph of this h units to the right. That makes sense? If h is negative, you shift absolute value of h units to the to the left, right? So, and then this, if k is positive, you shift k unit up. If k is negative, you shift k unit down. So let me give you one example, okay? I'll show you like how does it work, okay? So I just like to show you here, okay? Because you may not look here. So let's say, for example, this is positive 2, for example, okay? You see that, right? I want to graph this. Look here. How does it work, okay? I want to graph here. Look. So the graph of the basic function is this. This is given, okay? So this, let me show you. Okay? So you guys know the graph of fx equal to x squared, which is a parabola open upward like this, passing through the origin. Is that right? So this is graph of fx equal to x squared. Are you guys with me? This one, right? So, first of all, look here. What is the value of a? You compare this with y equal to a times x minus h squared plus k, okay? What is the value of a? 2. See, a equal to 2, right? You see that, a equal to 2. So this is positive, is that right? Right? So your parabola will be what? Vertically stretched. Vertically stretched. That makes sense? And the vertically stretched means, you see, your parabola will be more narrower, right? So your parabola will be, because you know a equal to 2. So fx equal to x squared, if you want to draw the graph of, let's say, gx equal to 2x squared, what does it look like? So you have this is your fx equal to x squared, right? So when you plug in 0, it will be 0. Here, when you plug in 1, it will be 1, 1 here, right? But here, when you plug in 1, it will be 1, what? 2. Did you see that? So the point will be 1, 2. It will be, for this one, your graph 1, 2 will be 1, this is 1, 1. This is 1, 1 for this one, but it will be 1, 2. So it will be here, right here. Are you guys with me? Right? And then, similarly, hey, if I plug in -1 here for this one, if I plug in -1, it will be 1, -1, 1. Is that right? So -1, this is -1, 1. It will be here. But for this one, fx equal to 2x squared, if I plug in -1, it will be 2 times parenthesis -1 squared. Is that right? So it will be right here. You see that? And the graph looks like what? The graph looks like this. Did you see that? So the black one is the graph of what? Gx equal to 2x squared. So what did you observe here? The black graph is vertical stretching of red one by a factor 2. You see what I'm talking? And this is more narrower. The black one is more narrower. Does that make sense? The same thing happened here. So if you look here, so this one, it is what? Vertically stretched. See that? Now next one is, look at the value of h. So this red one is the graph of fx equal to 2x square. Now, look at the value of h. What is the value of h? What is the value of h? 1. Is that right? If we compare this with a parenthesis x minus h square plus k, what is the value of h? 1. This is positive, is that right? Is that right? If h is positive, your parabola will shift it horizontally to the right. So this parabola, this red one, will be shifted how many units? 1 unit to the right. So now this parabola, this red one, will be shifted 1 unit. So this point will be here. If this is 0, 0, it will be 1, 0. Shifted 1 unit. Now this point, so this point will be shifted 1 unit to the right. And this point will be shifted 1 unit to the right. Are you guys with me? You see, it will be shifted 1 unit to the right. That makes sense? Right? So now you'll have you'll have something like the let me use the blue one. So this is a parabola. This is not a straight line, okay? You'll have something like this. Are you guys with me? You'll have something like this. Did you see that? So now this blue one is what? Fx equal to, let's say you can say hx or whatever, it doesn't matter. Fx equal to 2 parenthesis x minus 1 square. Did that make sense? You shift it 1 unit to the right. And then you look at the value of k, the value of k is 3, is that right? Value of k is 3. And this is positive. If k is positive, you shift the blue one, how many unit? 3 unit up. So now this graph will be, like this one will be shifted, this one will be shifted 3 unit. Now this is 1, 0, so it will go here like it shifted 3 unit. You know what I mean? So if it is 1, 0, so if you shift like 3 unit, what will be this is? So it will be, what is this, guys? 1, 3. Somewhere here, which is 1, 3. And then like you will have something like this. Are you guys with me? It is shifted. Every point of this one is shifted 3 unit up. Did you see that? So that's what so it is, you know what I'm talking, right? Huh? So what I did here is you have a original graph. You have an original graph of fx equal to x square, something like this. It has been stretched vertically by a factor of 2 unit, so that it looks like this. It looks like this, right? And then you shifted this. How many unit? 1 unit to the right. Okay. So you shifted this 1 unit to the right. You got something like this, right? And then you shift 3 unit up. So if you shift 3 unit up, then you got something like this. You shift 3 unit up. You know what I mean? So you something like this. Does that make sense? Okay. Okay. Now graph each function. Give the domain and range. So you have fx equal to x square minus 4x minus 2. and you have to find out, you have to graph and then find the domain and range. So you graph fx equal to x squared minus 4x minus 2, and then you need to find the domain and you need to find the what? Range. So hey, first of all, if you wanna graph quadratic function, I encourage you to find the vertex. And the vertex is denoted by h comma k, the vertex of a quadratic function. The parabola is denoted by h comma k, and this h is negative b over 2a, and the k is the function f evaluated at h. See that? So now, if you want to find the vertex of this parabola, this quadratic function, you compare this with fx equal to ax squared plus bx plus c. You compare with that one, and so here h equals to negative, what is the value of b? What is the value of b? Negative 4 over 2 times, what is the value of a? What is the value of a? 1. So now that will give you 4 over 2, which is what? 2. So the value of h is 2. So this is the x value, x coordinate of the vertex. And then if you want to find the value of k, you just evaluate this function at h equal to 2. So this is f2. So now you plug in 2 here. So that will give you 2 squared minus 4 times 2 minus 2. That makes sense? And so it's going to be 2 squared is 4 minus 4 times 2 is 8 minus 2. So 4 minus 10, which is what? Negative 6. So now what is the vertex? The vertex of the parabola is 2 comma negative 6. So the vertex which is denoted by h comma k is negative 2 comma 2 comma negative 6, sorry. Okay, and then you find out 2 points to the left of 2, and another 2 points to the right of positive 2. What I'm trying to say is you have x value and y value. You know the vertex is 2 comma negative 6. X value of the vertex is 2 comma negative 6, right? And you know the graph of the quadratic function will be parabola. You know that. And in this case, the parabola will open up because the value of a is positive. Value of a equal to 1. So a equal to 1, which is positive. So that means the parabola open up like this. Open up. So hey, look here. Now you have a number line here. I'll show you this. So 2 is, look at the x value of the vertex, which is 2. 2 is right here. So I'm going to take at least 2 points to the left of 2 and 2 points to the right of 2. So if this is 2, I want to pick 1 and 0, and if I want to pick negative 1, that's fine, right? Right? And then another 2 values to the right. So 3, 4, 5. Did you see that? So the x values are 2, 1, 0, negative 1, or you can do 3, 4, 5. Now, You plug in 1 in your quadratic function, okay? Your quadratic function is fx equal to x squared minus 4x minus 2. You plug in 1, right? What will be this? 1 squared is 1, minus 4 times 1 is 4, minus 2. So f of 1 is 1 minus 6 equal to what? Negative 5. That makes sense? Right? So now you got this is 1 comma negative 5. You see that? Are you with me? And then you plug in 0. X equal to 0. If you plug in x equal to 0, what will be this is? Negative 2. Right? And then you plug in negative 1. If we plug in negative 1, what will be this? So this is negative 1 squared minus 4 times negative 1 minus 2. So it will be f of negative 1 equal to positive 1, negative times negative positive 4 minus what? 2. Good? So this is 1 plus 4, 5 minus 2 is what? 3. So negative 1 corresponds with 3. Now, what you need to know is the graph of the parabola will be symmetric. Is that right? Symmetric with respect to the what? Axis of symmetry. Right? So now if you see this 1 and 3, look here guys, this 1 and 3 are equidistant, are at equal distance from the what? X value of the vertex. What is the x value of the vertex? 2. Is that right? This 3 is 1 unit to the right. This 1 is 1 unit to the left. Is that right? So now, so that means if we evaluate this function fx equal to x squared minus 4x minus 2 at x equal to 3, you will get this negative 5. Because you know the graph is symmetric. You can check it, you know. Look here. So if I plug in 3 here, if I plug in 3, x equal to 3 here, so f3 is 3 squared minus 4 times 3 minus 2. Is that right? So now this f3 is, this is 9 minus 12 minus 2. So this is f3 equal to 9 minus 14, which is what? Negative 5. See that? So this is negative 5. Now similarly this 4 and 0. This 4 and 0, they are at 2 unit. This one is 2 unit to the right from x value of the vertex. What is the x value of the vertex? 2. And this is also 2 unit. Right? So they are at equidistant, at equal distance from the what? X value of the vertex. So if you evaluate this quadratic function at x equal to 4, what would you get? Negative 2. And this will be what? 3. Are you guys with me? And now, if you want to draw the graph, look here. So this is your x-axis, and this is your y-axis. So first of all, you plot the vertex. The vertex is 2 comma negative 6. So 2 comma negative 6. This is 1, 2, 1, 2, negative 6, 1, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. So 2 comma negative 6. So this is the vertex. So this is 2 comma negative 6. See that? And then you have a 1 comma negative 5. So 1, this is 1 comma negative 5. Negative 5 is 1 unit, this is 0, right? Origin 1 unit right, negative 5 right here. You got it? And then you have a what? 3 comma negative 5. So 3, 1, 2, 3. 3 comma negative 5. 3 unit right, 5 unit down. So you have a 3 comma negative 5. Are you guys with me? So this is what? 3 comma negative 5. Right? This point is 3 comma negative 5. This point is 1 comma negative 5. This one. And then you have a 0 comma negative 2. 0 comma negative 2 is right here. This point is 0 comma negative 2. And then you have a 4 comma negative 2. So let's say this is 4 comma negative 2 is right here. So this point is 4 comma negative 2. And now negative 1 comma 3. So let's say this is negative 1. So 1, 2, 3. So negative 1 comma 3. This point. And then you have a 5 comma positive 3. So this is, let's say, 5 comma positive 3. This point. Did you see that? And now if you join them, so what does it look like, guys? Look here. You join them, okay? So you just like did you see that? You got a parabola. Open upward. This is the vertex. And the line of symmetry, or people also say axis of symmetry. So people call axis of symmetry is x equal to h. Okay? And x equal to, what is the value of h? What is the value of h? What is the x value of the vertex? You guys know that, right? Because vertex is what? 2 comma negative 6. What is the value of h? 2. So x equal to 2 is the axis of symmetry. So x equal to 2 is the axis of symmetry. Now you see, if you can draw like this line is axis of symmetry. Are you with me, guys? Right? Yeah. The right half and the left half. If you look at the axis of symmetry here, the right half and the left half, they exactly fit with each other. That makes sense? They are symmetric. Okay. So we got it, guys. And the domain, you see, what will be the domain? What will be the domain? Exactly, yeah. The domain is negative infinity, comma positive infinity. So this is the domain. And what will be the range? No, you got to be careful. The range is, now you see, because below this line, you know what I mean? This this line, below this line, your graph is only above this line. You know what I mean? So your graph does not go below this line. So what is the lowest? What is the least y value? Negative 6, is that right? You see what I'm talking, right? So, look here. So you have a graph like this, guys. And this point is 2 comma negative 6, is that right? So your graph, it does not go below this line. Sorry. Hold on a minute. Your graph does not go below this line, does it? No. So that's why your range, the range of this parabola will be this. This. So what is the least y value? Negative 6. And what is the greatest y value? Positive infinity. Is that right? So The range is, you can include -6, positive infinity. So now, the thing is this. Let me give you the formula, okay? If the parabola open up, so that means A is positive, right? If A is positive, your parabola open up. If the parabola open up, the range will be k, positive infinity. Are you with me? This parabola open up, so that's why the range is k, positive infinity, and the value of k is -6. So that's why -6, but you include -6. That makes sense. If parabola open down, the parabola open down if A is less than 0. Is that right? If A is negative. So in that case, your range is going to be negative infinity. So this negative infinity, k. So this is because, let's say, if you have a parabola like this, so this is your x-axis, this is your y-axis, and let's say you have a parabola something like this. Right? What will be the range? So this is your HK, is that right? This is the vertex, is that right? So what will be the range? The range is negative infinity all the way up to k. So this is negative infinity all the way up to k. You got it? And now, hey, look here. So graph each function, give domain, and then like for the quadratic function, if you have a vertical parabola, it doesn't matter whether it is open up or open down, the domain is always going to be negative infinity, positive infinity. Okay? So now you see here the graph, each function, give the domain and range. Let's do this one, okay? Now this one. So if you look here, guys, if you have, let's say, look here. So if you have a function, you want to graph the function f(x) equal to, you want to graph this. Graph f(x) equal to -1/2 x minus 4 square plus 3. Okay? So what you need to know is, the graph of the basic function f(x) equal to x square. f(x) equal to x square, it looks like what? This. Is that right? And then, so this is your f(x) equal to x square. And now what is the value of a here? So value of a is -1/2. So this is, now remember, if 0 is less than absolute value of a is less than 1, what is the absolute value of a? Absolute value of a here is 1/2. Is that right? Is that right? So if this is the case, your graph will vertically what? Vertically shrunk by a factor of what? 1/2. That makes sense? So now, if it is vertically shrunk, you see it will be more wider. The graph will be more wider. So this is going to be the graph of what? f(x) equal to, let's say y equal to half x square. It is vertically what? Vertically shrunk. But you have a negative here. You see that? So that means the parabola open down. Right? Or you can simply reflect this across the what? X-axis. This is your x-axis, this is your y-axis, you reflect that. Are you guys with me? If you have a y equal to fx, right, then the graph of y equal to negative fx is the reflection of y equal to fx across x-axis. So what I'm saying is this, guys. Remember, if you have a y equal to fx, it is given. Given graph, okay? Given. And for particular case, you can pick y equal to what? X square. Right? This is given. This is given. Now, y equal to negative fx is the graph of y equal to negative fx is the reflection of y equal to fx across x-axis. You see what I'm talking? So in this case, this is your y equal to fx, and you see y equal to negative fx will be negative x square, right? Now the graph of negative y equal to negative x square is you reflect this graph, you reflect, this is your x-axis, you reflect this across x-axis, you reflect. This will be a meter, look like a meter. You know what I mean? This x-axis is a meter. And then when you reflect this, it looks like this. Do you get it? So now here this is y equal to half x square, but we have a negative 1/2, so you reflect this. So you reflect green graph, you reflect this, then you'll have something like this. Agree? So now this is the graph of what? Y equal to negative half x square. That makes sense. And then look here. You shift this graph, the red one, how many units? 4 units. In which direction? Left or right? Remember when you have a fx equal to a times x minus h square plus k, if h is positive, right? Then you shift the graph of y equal to x square. How many units? H units to the what? To the right. That makes sense? So now you shift this h units to the right. So if you shift h units to the right, so it will be something like this. You know, you go this graph shift right. Okay. So how many units? 4 units. So if it is 0, 0, now the vertex will be 4, 0. Shift unit right. Are you guys with me, guys? Are you with me? It's something like this. Right? And then that graph is shifted how many units? 3 units up. So this point, you go like a 3 unit. 1 unit up. This is 1 unit up. 2 unit up. And then 3 unit up. So it goes right here. So now you have something like the final graph. The final graph looks like. Are you guys with me? Am I making sense here? This. So this is the point 4, 3. So this is the vertex. The vertex is 4, 3. Make sense? Yeah. And you see the domain is negative infinity, positive infinity, and what is the range?
3,
Negative infinity, 3. Yeah. So here the domain is any quadratic function has the domain negative infinity, positive infinity, range. I told you this is the parabola open downward, right? Open downward. if that is the case, the range will be in the form of negative infinity comma k, and here negative infinity. And what is the value of k? What is the value of k? Is 3. Okay, guys, so now you can do the same thing here. Like if you find graph fx equal to x squared minus 6x plus 7, find the largest open interval over which the function is increasing or decreasing. So, hey, first of all, let me write down this in the form of, if you have the quadratic function fx equal to ax squared plus bx plus c, where a is not equal to 0, so the vertex form, what I'm writing here, the vertex form of the equation is a parenthesis x minus h squared plus k. So this is the vertex form. Okay? So now, what do you have here? So we have a function fx equal to x squared minus 6x plus 7. I want to rewrite this in a vertex form. Okay? I want to rewrite this in the vertex form. But how do I write that? So the thing is this, guys. So now value of a is 1 here. So I wanna use the method of completing the square. You know, the completing the square method. So x squared minus 6x. I'll group this and write down plus 7 here. Look here. What is the coefficient of x here? Negative 6, right? Negative 6. So coefficient of x is negative 6. Find half of negative 6. What is half of negative 6? Negative 3, right? Half of negative 6 is negative 3. Square that. What did you get? 9, is that right? You add and subtract 9. Because if you add and subtract the same number, this is 0. So what I'm saying is you can do here plus 9 and minus 9. Because this is, you can do that because this is basically, this is what? 0. And you can add 0, right? It doesn't make any difference. That makes sense? Are you guys with me? So now, after doing that, you can simply write this is x squared minus 6x plus 9. You can group them, and this is negative 9 plus 7. Negative 9 plus 7. So hey, can you factor this? This is x squared minus 6x plus 9 is same as x minus 3 times x minus 3. Is that right? Right? And what is negative 9 plus 7? Negative 2. Are you with me? And so it is going to be fx equal to x minus 3 squared minus 2. Now, this is in the vertex form. Right? What is the value of a? A is 1. What is the value of h? What is the value of h? You compare this with fx equal to, fx equal to a times x minus h squared plus k. Compare. What is the value of a? 1. What is the value of h? No, h is, you compare this, x minus h is squared with x minus 3 is squared. What is the value of h? 3. H is 3. What is the value of k? Negative 2.
I have a question.
Yes.
So the value of h you always keep negative?
Value of,
I mean the negative sign will always be in front of the value of h.
so the thing is this, okay.
So what if it's negative times a negative?
Negative,
What happens?
yeah, I think like if I, so let's say if you have a, something like this, right? So if you want to compare this with this, right? So what will be the value of h?
Negative 4.
Negative 4.
Okay.
Did you get it?
Yeah.
Because you can rewrite this in the form of, let's say this is 2. This is same as x minus negative 4, because negative times negative positive 4. Is that right? A square plus, because if you want to write in this form, this is plus negative 3. Now this and this, they are equivalent. Is that right?
Yeah.
So now you can see that what is the value of h? Negative 4. What is the value of k? Negative 3.
Yeah.
Yeah.
That's what I figured it was. I was just curious.
Yeah. So now here, if we compare this like x minus h squared, what is the value of h3? What is the value of k? Negative 2, because this is same as what? Plus times negative 2. You know what I mean? Right? So now what is the vertex? You got the vertex, right? What is the vertex? The vertex is 3, negative 2. That makes sense? Now, if you want to draw the graph of this function, if you want to draw the graph of this function, fx equal to, if you want to draw the graph of this function, so fx equal to, you have x minus 3 square minus 2, right? So if you want to draw the graph of this function, so look here. This is your graph of basic function fx equal to x square. So this is fx equal to x square. You guys know that, right? Is that right? This. Then you shift this graph. How many units? 3 units. In which direction? Left or right? Remember? So this is given. Y equal to x squared is given, right? So if you have a y equal to a parenthesis x minus ac square plus k, if ac is positive, you shift the graph. How many units? H units, right? Horizontal. So you will have a horizontal shift of h units to right. Is that right? Right? So now here you see what is the value of h? 3. So you shift this 3 unit to the right. So now, so 3 unit to the right. So this will be 0, 1, 2, 3. You reach here. You know what I mean? So now you will have something like, so you 3 units to the right. So you'll have something like, are you with me, guys? Yes? And then, now look here. So if k is positive, you shift k unit up, right? If k is negative, you shift k unit down. You know that, right? If k is positive, vertical shift of k units up. If k is negative, vertical shift of k units down. Now, what is the value of k? Positive or negative? Negative. So what do? You shift k unit down. So now here k is 2. K is, negative 2. This is negative. This is negative. So you shift the graph vertically down. Shift 2 units vertically down. So that means this point will be shifted 2 units down. So this is negative 1, negative 2. Are you guys with me? So you shift it down. You know what I mean? Every point will be shifted 2 units down here. This one shifted 2 units down. This one shifted 2 units down. Are you guys with me? Right? So now it's shifted 2 units down. This point will be shifted 2 units down. This point will be shifted 2 units down. Does that make sense? This point will be shifted 2 units down right here. Are you with me? So now the graph looks like something like this. Right? Are you with me? So now the graph is, the final graph is, makes sense, right? Right? So the final graph is this. And what is the domain? What is the domain? The domain is negative infinity, positive infinity. Right? And what will be the range? What will be the range? Negative 2 all the way up to what? Positive infinity. So it's going to be negative 2, positive infinity. I think you got it, right? Right? Yeah. And by the way, you have to find out the largest open interval over which the function is increasing. Largest open interval open interval over which the function is increasing. Look here, the function is increasing here. The function is increasing here. This is increasing. Is that right? Increasing, right? Increasing. You see that? The function is increasing. This is increasing right here. But what is the open interval on the domain where the function is increasing? So if you want to find out the open interval where the function is increasing, this open interval. Did you see that? This. Right? So it's going to be, what is the vertex? 3, negative 2. Is that right? So this is 3, negative 2. So the open interval over which the function is increasing is 3 all the way up to positive infinity. Right? So largest open interval over which the function is increasing is 3, positive infinity. And this is open interval, open. Are you with me? And the largest open interval over which the function is decreasing. Did you see the decreasing here? Decreasing? So the open interval on the domain. You know what I mean? Right? So from negative infinity all the way up to positive 3, your function is what? Decreasing. That makes sense? Right? And the largest open interval over which the function is, are you guys with me? Function is decreasing. So decreasing is, what is that? What is the largest open interval over which the function is decreasing? Negative infinity all the way up to 3. Negative infinity, 3. Make sense, guys? Yeah. Okay. Now you can do that, okay? So we talked about that, right? So So you can find the axis and the vertex of this parabola. You can do that, right? So axis and the vertex. There are two methods. One is, so what is that? Find the axis and the vertex of the parabola. Fx equal to 2x squared plus 4x plus 5. If you want to find the vertex, you can use this formula, h equal to negative b over 2a and k equal to f of h. Does that make sense? Now you compare this with fx equal to ax squared plus bx plus c. So what is the value of a? The value of a is 2, b is 4, and c is 5. So now h equals to negative, b is 4, negative 4 over 2 times, what is the value of a? Is 2. Are you guys with me? So that's going to be negative 1, right? 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 And then k will be f of negative 1. So you plug in negative 1 here. So this is 2 times negative 1 squared plus 4 times negative 1 plus what? 5. Right? Good? So what is this? K equal to negative 1 squared is 1, so 2 times 1 is 2. This is positive times negative 4 and plus 5. So that will give you k equal to 2 plus 5 is 7. 7 minus 4 is what? 3. So now vertex equal to negative 1, comma 3. Right? And the axis of the parabola so if you want to find out the axis of the parabola, you just simply do x equal to h. So this is the equation. X equal to h is the axis of the parabola. So that is x equal to, what is the value of h? Negative 1. This is the axis of the parabola. Are you guys with me? Now, can you read this? If air resistance is neglected, the height of an object projected directly upward from an initial height s 0 feet with initial velocity v 0 feet per second is given by this. Okay? See that? Right? So what is this? St is the height, right? So you have st equal to negative 16t squared plus v0t plus s of 0. So this is the initial height. So now look here, guys. So a ball is projected directly upward from an initial height of 100 feet, an initial velocity. So this v0 is the initial velocity. Okay? So the initial velocity is what? 80. So this is 80t plus, what is the initial height? 100. So this is 100 plus, this is what? Negative 16t squared. Right? So if you look here, look at here, okay? v0 is 80, s0 is 100, and then you plug in here, you got it. So this is the quadratic function. Did you see that? And now, if you look here, after how many seconds does the projectile reach its maximum height? Okay, hey, I am running out of the time. I will see you next week. Tuesday. Okay, yep, I want to stop here. Bye.